Hello, I'm Nitin Dahat with EE Times, and I'm here at the HiPEAC 2024 conference in Munich, Germany, talking to Marc Duranton, who's a senior fellow at CEA and also editor of the HiPEAC Vision 2024. Marc, hello.
Hello, how are you?
Good, thank you. Well, it's been a very fascinating conference. It's one of the conferences where you can actually talk to researchers, professors, and engineers, and that's because of the HiPEAC community. Marc, tell us a little bit about this community.
So this community was built nearly 20 years ago, and at the origin it was to build the bridge between research and industry on computing system. And when I mean computing system is not only hardware or software, but it's both of them. So it's really having a synergy between all this domain and to try to define how to advance computing system, which is the basis of all application of all our digital world of today.
And this is the 19th year, so next year will be the 20th anniversary, yes. But there's been some interesting sort of achievements over the years, I guess?
Yeah, several ones. So we evolved a little bit. At the origin, HiPEAC was very high-performance centric, so now we are more moving towards embedded system, cloud, and now the keyword is a continuum of computing. So this system will smooth application between edge computing to the cloud, and this is what is the new trend today.
And one of the things I've been writing about over the last few years is when you've released the HiPEAC Vision roadmap. Tell me a little bit about, first of all, background. HiPEAC is an EU-funded project, but actually it's globally relevant. So can you just tell us a little bit about that background?
Yeah, well, in fact, technically we are in HiPEAC 7, so it's the 7th iteration of European project. So from European project, we have to do some deliverable. So the HiPEAC conference is one of the deliverables. So here to put all the community together, but also the HiPEAC Vision is also a deliverable. So in HiPEAC 7, the European Commission asked us to make this vision every year. Contrary to the past where we did it every 2 years, because the pace of innovation is really increasing now.
Yes, and one of the things I think I sort of picked up over the last few years has been, as you talked about, the continuum of computing, and that sort of comes out quite strongly in this year's Vision. So tell us a little bit about the summary of Vision 2024 and what that means. Also, like, it's not just a document in itself, it's actually sort of mapping what's coming in the future.
Yeah, well, it's our vision of the future of the domain. And as you say, we have a lot of technology that emerged in the past, like cloud, like cyber physical system, like IoT, like artificial intelligence. And now in our vision, all these ingredients will morph together into what we call the next computing paradigm, where basically man and machine will smoothly interact through intelligent devices that could build application from the need of the users. So basically, the idea is that you will have a collection of services that will be interconnected by smart orchestrators.
That's right. And one of the things I think came out in, and just to give you an example of how what you do sort of reflects what's coming in the future. So I think not the last Vision report, maybe the one before, you talked about the complexity of chip design and as a result needing that AI. And then lo and behold, over the last 2 years, we've seen Synopsys, Cadence launch AI tools for EDA and AI in EDA. So it's quite a sort of foreteller of what's coming.
Yes. We are in our field. Really, the key bottleneck is the complexity. We have more and more complex system, and the complexity is behind what one human mind could grasp. So it's why we have all this abstraction layer. So we have network layer, we have operating system, and things like that. But all these layers also add inefficiencies. So if we want to be more efficient, you need to have the global view so that you could optimize across all the layers. But this is very difficult, so we need tools. And artificial intelligence could be one of these tools that could allow to optimize cross layers. Yeah. So you already know with generative AI that we could generate code. And the next generation might be also able to help in generating hardware. So at least for the time being, it's not doing it automatically, but it's really what we called that this is a synergy between people, engineers, on this system that could increase productivity and efficiency.
And now, coming to this year's report, you talk about the next computing paradigm. This sort of pulls together the 6 races you produced in the last report. Maybe just summarize that for us a little bit.
Yeah. So we see that the world is going very fast, and we are in a lot of races. So races over time, because we have the constraints of the global warming. So that's an external constraint. We have also innovation. So artificial intelligence is going very fast. What we wrote last year, so we were predicting. For example, that a large language model will run at the edge. So at that time, this was, we expected that this will happen in 2-3 years, but it's already available now.
Yes.
So this is going very fast. And of course, we have all the political constraints and economical constraints. So we are in a race. So we identify several races. So one is to build this next web, this next computing paradigm. So people talk about the Web 3.0 or Web 3, but we are seeing something which is more global than this. So really embedded the complete computing architecture from edge to cloud into something that is more unified in technology. So please go to the vision document if you need more information. So one of the race, of course, is the one of artificial intelligence, which is going very fast. We need also to tackle with cybersecurity, which is really also a major issue today, even going to the cyber war that we are seeing today. But for this, we need also to define new hardware, so new efficient hardware. So that's very important. And this hardware need to be sustainable. So that's also a big message here. We need to have this sustainability.
Yeah, and I think our conversations over the years have been very focused on sustainability, and with the next computing paradigm, that becomes even more important. And we've seen in some of the keynotes here on, for example, the supercomputer this morning about the need for efficiency.
Exactly.
So do you want to emphasize that sustainability aspect in?
For a very long time, a computing system only focus in sustainability in one domain, it's energy efficiency. Yeah. So I think this was one area where we were very successful. I think in 30 years, we gain 2 million in terms of efficiency in operation per watt. So I don't know any other domain that were so high gain in 3 decades. But energy efficiency is not only the key domain now for sustainability. We know also to fight with the global warming CO2. And you know that for some electronic devices like smartphone, the CO2 are not generated during the use, but during the fabrication, the building of the system. So when you buy a smartphone, it's several tenths of kilograms of CO2 that you already have before even using it. Yeah. And of course, there are also some other challenges because we need rare earth materials that are not very green to extract and to purify.
Now, coming to some of our E-Times audience, you talk about needing new hardware and then software. I think from what I understood from reading the report, it's basically around sort of hardware that enables all of this, but also like the software APIs that enable the orchestration.
Yes. So again, in the past, software was really local. So you had a file, that you compile, and this is your application.
Yeah.
So now one application is distributed. When you are in fact using an application, it's getting data from a smart sensor, which are a few meters away, and they could get information from the web, which are thousands of kilometers away. So in fact, now an application is a gathering of several other things. It's not a single file that is making an application. I think the best example of this linked to computer languages is Python. So when you see Python, it's more an orchestrator of library. In fact, most of the computation are done with the library, which are glued together with the Python interpreter. So, and we see now that in the next generation of computing, this is not only at the level of programming language, but also at the level of devices. So each devices will offer a services, and then this will be orchestrated by you or by a smart orchestrator because of the complexity of selecting which services, which API, and things like that. So that's the bottleneck that we have to solve for this.
Okay, well, I've written quite a lot about it, and you've got the report, but what's been the highlight for you from this conference?
Well, I think that indeed, as you say, I think one of the highlights is sustainability.
Okay.
So we cannot continue to grow in a computing system without taking sustainability into account. Of course, we have to cope with the rebound effect, so or Jevons paradox. So the Jevons paradox is that when you make something more efficient or cheaper, globally people will use it more. So globally, it's also increasing.
Yeah.
So we need also to have some societal aspect of nice use of computing systems.
And now, like there were more than 600 people at this conference, and for the 20th anniversary, it's going to be back in Barcelona, where it started. Is that right?
Yes. The first conference was in Barcelona, and now we want to close the loop at least for the 20th anniversary.
Oh, good. Well, Marc, thank you very much.
So thank you.